So today we're going to start into 7.4. We were going to do 7.3 today, but tomorrow is the college fair. I don't remember the times exactly, but I know a lot of students will be gone or in and out of class, and this section is probably the more difficult of 7.3 or 7.4 because 7.3 just piggybacks off of 7.2, which we just did. Okay, so we're talking about properties of special parallelograms. And we will be learning about the properties of these special parallelograms. You wrote them down on that chart. We're going to be talking about rectangles, rhombuses, and squares. There are obviously more parallelograms, but these are the ones that we are dealing with. And then we're going to use the properties of their diagonals. Go ahead and turn to page 212 of your student journal. We will begin there and then eventually get to the chart that you drew. All right, so if you look at the top left of page 212, you're going to see the names of those. Some of you earlier looked at me and were like, what in the world is a rhombus? A rhombus is a parallelogram with 4 congruent sides. So it's a type of parallelogram, which means it has all of the properties of a parallelogram, and it has 4 congruent sides. So it's a very special parallelogram. You can go ahead and write that in the term section, the top left of page 212. A rhombus is a parallelogram with 4 congruent sides. So if it has the properties of a parallelogram, how many properties are there to a parallelogram? You've written them down 3 or 4 times now. There are 4 properties. Can you name the very first property for me? Go ahead, Tyler. Yeah, opposite sides are congruent and parallel. George, can you name the second property of a parallelogram?
Opposite angles are congruent.
Opposite angles are congruent. Gabby, do you have the third?
Consecutive angles are supplementary.
Consecutive angles are supplementary. And Abby, you have the fourth.
Diagonals bisect each other.
Diagonals bisect each other. So a rhombus has all of those properties as well as it has 4 congruent sides. The second kind you're talking about is a rectangle. It is also a parallelogram, so it also has all of those 4 properties. But it also has 4 right angles. So a rectangle is a parallelogram with 4 right angles. And the last, if a rhombus and a rectangle got together, had a baby, it would be a square, because a square is a parallelogram with 4 congruent sides, just like a rhombus, and 4 right angles, just like a rectangle. So whatever properties a rhombus has, a square also has. Whatever properties a rectangle has, a square also has. So if you're looking in your student journal, there's like 1, 2, 3, 4, 5, 6 theorems on that page. So instead of you having to write out the theorems or memorize the theorems, you made that chart, which is what we're going to be doing in a few seconds. But what I've done is made a Venn diagram to just kind of show you the relationships that they have. So in the beginning, God created the heaven and the earth, and eventually there were parallelograms. Okay, so all of these are parallelograms. And then they're split off this specific section called rhombuses. And they all have congruent sides. They could look like any of these. And then there are rectangles. And then there is a square. So again, whatever property a rhombus has, a square also has, because a square is a type of rhombus. Whatever properties a rectangle has, a square also has, because a square is a rectangle. Y'all see that? So you're going to learn all of the properties using your chart. So you can pull that out. So in each section, it's going to say, in the diagram, you're given rectangle ABCD. So if you're given a rectangle, you can use this chart to see which properties apply to a rectangle, apply to a rhombus, and apply to a square. Okay? So the very first is all of the parallelogram properties. Which of these are parallelograms? All of them. So they all have the properties of a parallelogram. So all of their opposite sides are congruent and parallel. All of their opposite angles are congruent. Consecutive angles are supplementary, and diagonals are bisected. All of those properties apply to each of them. The second, all sides are congruent to each other. Okay? What is the definition of a rhombus? Parallelogram with 4 congruent sides. So all the sides are congruent in a rhombus and in a square, because a square is a type of rhombus. The third, angles are bisected by diagonals. This is a rhombus, which means it also works for a square. The third, the diagonals are perpendicular. This will also work for a rhombus and a square. And then I'm going to stop and draw you one. Okay, it's not perfect. I'm not perfect. So what happens is you have these diagonals. Look like this. Okay, so the diagonals cut the angles perfectly in half. So let's think about this. Let's say that this angle was 25. Okay? What does that mean the other half of the angle is for a rhombus? 25. Okay? A rhombus is also a parallelogram. What do you know about the opposite angles in a parallelogram? They're congruent. So that means the sides across, or the angles across, are 25 and 25 as well. And the last, the diagonals are perpendicular. When two things intersect and they're perpendicular, what do they form together? A 90-degree angle. So it's not going to be there. It's not going to have that right angle. That means all of these are right angles. It's not going to be drawn there. You're going to have to know it by yourself. Okay, so it might help for you to draw this. If I were you, this is a rhombus. If you want to write that next to it. Rhombus. And it illustrates the two properties that the diagonals bisect angles and the diagonals are perpendicular in the center. The next quality are all angles are 90 degrees. Does this fit for a rectangle? Yes, it does. Does it fit for a rhombus? No, it does not. Does it fit for a square? Yes. A square is a type of rectangle. The last, whole diagonals are congruent. This does fit for a rectangle, which means it also fits for a square. And I will also illustrate that for you. Alright, so it says whole diagonals are congruent. Okay, so let's pretend that this rectangle is beautiful and it's perfect. If one of the diagonals was 15 centimeters, okay, making it up, that means the other diagonal is also 15 centimeters. Okay, so that property fits for rectangles and for squares. If you know all of these properties, you can solve any type of problem. Alright, so we're going to use them. This is our first example. Classifying the special quadrilateral and explain your reasoning. So I condensed the chart that you have on the screen. You already wrote it down in a different format, but this is just so we can do process of elimination. This is either a rectangle, a square, or a rhombus. And then you have to explain why. Okay? So the first thing that I notice about this shape are the sides. What do those dashes mean on the sides? They're congruent. So, does a rectangle have all congruent sides? No. Does a square? Yes, all sides are congruent. Does a rhombus? Yes, all sides are congruent. So it's either a rhombus or a square. After that, you'd look at the angle. The angle that you're given is 70 degrees. But what do you know about the angles in a square? They're all 90. So if one of these angles are 70, are all of the angles in the shape 90? No. So it's not a square. So what does that leave? Rhombus. And then it says explain why. So it's a rhombus because all these sides are congruent. All right, and then how did we narrow it down from square to rhombus? All the sides being congruent makes it either a square or rhombus. How did we decide a rhombus? Because, and not all the angles are 90. All right, so when you get to the section that says explain to the best of your abilities how you decided, how you went down to your decision. Okay? Our next example, I require you to draw. It's this picture up here. Go ahead and draw this. All right, so we're going to find the measure of angle 1, the measure of angle 2, the measure of angle 3, the measure of angle 4. So when you take this quiz on Friday, keep in mind I have 93 papers to grade. So do not just write on the picture. Make sure you write on the side somewhere where your answers are. All right, so very first thing we want to do is decide which of these shapes we're talking about. Is it a rectangle, a square, or a rhombus? A rhombus. How'd you know that?
61.
Says it in the directions. Was not a trick question. Most students don't actually read the directions, and it's going to happen in this class. You just watch in a few minutes. So it's a rhombus, so we're dealing with all of these properties. All the sides are congruent. The diagonals bisect angles. The diagonals are perpendicular at their intersection. Then they have all of the other parallelogram properties. Okay, so if you want to start with angle 1 is the angle at the intersection of the two diagonals. What do you know about the intersection of the two diagonals? It says it right there on the screen. What happens when you have a rhombus and you have your diagonals intersecting? What do they form? 90-degree angle because they're perpendicular. So if all of these are 90, what's the measure of angle 1? 90 degrees. That will happen every single time. That's a given. It's not going to change for a rhombus or a square. All right, to find the second and third, if you look at the corner of angle C, okay, what do you know about the diagonals? What do they do to the angles? Diagonals what? Bisect the angles. So if the left half of C is 61, the right half is 61, which means the whole angle, which will help us later, is 122. Okay? So look at this. If angle C is 61 and 61, remember that opposite angles are congruent of each other. So angles 2 and 3 have to also be 61 and 61. 61, 61. And then the last, you can solve one of two ways. If this whole angle of C is 122, yeah, angle D is right next to it, so they're consecutive. So they're supplementary. So what you could do, you know they're supplementary, so they add up to 180. If angle C is 122, you subtract it and you get 58. So the whole angle at D is 58. But angle 4 is only the top half. So it's half of 58. 29. You could have done it that way. This is the way that I prefer. I'll highlight it in pink. What shape did I just highlight? In pink. A triangle. What kind of triangle? A right triangle. Right triangle. See that right angle? So if you have a right triangle, you have a right angle, and you have 61 degrees. If you have two angles in a triangle, how do you find the third? Yep, add them and subtract from 180. Okay, and either way you do it, you get 29 degrees. Okay? In this picture, it's a little different. It says we're given a rectangle, QRST, and you're given QS, RT, and you are asked to find the lengths of the diagonals. So if you look at this, QS and RT, are they sides or diagonals? They're diagonals. What do you know about the diagonals of a rectangle? They're congruent. Looking at a rectangle, diagonals are congruent. So, if you know QS equals 5x minus 31 and RT equals 2x plus 11, what can you do to solve for how long there? Set them equal to each other. So you do 5x minus 31 equals 2x plus 11. All right, so I always move the smallest x first. What's the smallest x here? 2x. Subtract 2x, which means we're going to add 31. So 3x equals 42. Divide by 3. X equals 14. Did it ask what x was? It asked for the length of the diagonal. So what do I do with x?
Plug it back in.
Plug it back in. Does it matter which one I plug it into? No, because they're the same. I personally plug it into the simpler one, which would be 2x plus 11. What's 2 times 14? 28. What's 28 plus 11? 39. So you could have done the other one as well. I just didn't want to multiply 5 times 14. But you can. Questions on this? Okay. You guys are going to try in your student journal, page 214. All right, so looking at 3 through 5. BC. Well, first off, what shape are you looking at?
Square.
Rhombus. It says it in the directions. Rhombus. So what do you know about the sides of a rhombus? They're all congruent. So what's BC?
BC is 9.
9, because the other side's 9. All right, the next one, it says AC. This is a diagonal. So if AE is 7, that means EC is 7. So what is the length of the whole line? 14. All right, and this last part is what most people get incorrect. ADC, it's asking for this whole angle. All you're given in respect to angles, you got it right. All you're given in no, you're not. All you're given in respect to angles is this 44 degrees. All right, what do you know about the diagonals of a rhombus? Look at your properties. What do? They bisect. So if it bisects angle C, the other half is 44, which makes the whole angle 88. What do you know about angles that are consecutive? They're supplementary, which means they add up to 180. So if you have 88 degrees out of 180, it is 92. How many of you got that correct? Did you actually, though? Awesome. All right, go ahead and attempt 6 through 8. Okay, 6 through 8, what kind of shape are we looking at here? Rectangle. What do you know about the angles in a rectangle?
90.
They're all 90. Thank you, Christian. All 90. So it asks for us to first find angle FHG. FHG. So that's this angle right here. Okay. So this is where you're going to have to draw back a couple chapters. A rectangle is made up of two parallel lines. What is the line called that cuts through two parallel lines? Transversal. Thank you. So, because you have a transversal, alternate interior angles exist, which means if there's a 31 here, there's a 31 right here. So, if both of these angles at H combine to make 90 degrees, how do you find the angle that's missing?
You add it all up. You
Subtract from 90. So 90 minus 31 is 59 degrees. All right, the second, you have to read the directions to find the diagonal. It says EG is 17. What do you know about the diagonals of a rectangle? They're what? I heard someone. They're congruent. So if EG is 17, then FH is 17. All right, and then the last asks for EF, what is it? EFH, which is this angle over here, which is also going to be 59. Thank you. It's also alternate interior with the other angle we found, 59, 59. Or you could just take 90 and subtract 31 again, and you get 59. All right, this is the last, and we're going to do it together. The diagonals of a square, LM and P, intersect at K. Given that MK is 1/2, find the indicated measure. What do you know about the angles of a square? They're congruent, which makes them what?
90 degrees.
90 degrees.
Yes.
So pause. There's something else you know. A square is also a rhombus. So what happens when two diagonals intersect in a square? It's on your paper. What is it? They equal 90 because they are perpendicular. So all of these are 90. Also, since it's a square is also a rhombus, diagonals do bisect the angles in the corners of the square. So keep all that in mind. Number 9, we're going to find PK. What is the length of PK? 1/2, because MK is 1/2. It asks to find PKN. PKN, which is right here. We've already said it. How many degrees is it? 90. And the last is MNK. So where is that? MNK, yes. So, first off, you know the whole angle at N is 90, but the diagonal cuts into angle N. What do you know about the diagonals of a square? They bisect the angles. So, 90 divided by 2 is 45. Because the whole angle is 90, the diagonals of a square and a rhombus, they bisect. Yeah, they cut every angle in half. Go ahead and take out your textbook. You're going to begin on this section. It's only like 19 problems. It looks like a lot more because I singled some out. Okay, so take out a book and begin.